Okay, hello everyone. In this video, I will show you how to do task 1, 2, 3 of lab 2. So task 1 is to generate the key for RSA. Task 2 is encrypt a message. And task 3 is decrypting a message. So these three operations are the basic steps, basic applications of RSA. So let's go to task 1. So task 1 is deriving the private key from the information we have. So basically, the information we have is P, Q, E, and we want to compute N and D. The N is a big number for encryption or decryption. The D is the private key. So to compute the private key, we just use the extended Euclidean algorithm as we learn. Basically, is known as D equals e to the -1 mod phi n. This is also known as the module inverse. So actually, if you check the library document, we can find the module inverse function in the Bn library. As you can see here, Bn mod inverse Ban, that calculate the b that in this equation, a multiplied b mod n equals 1. So we can just use this function in the code. So the code is shown here, and you already have P, Q, E as we provided in the lab documents. Let me open the lab document here. So in the task 1, all right, you can see PQE here. Copy them. You can copy them to the code. So for the task 1, I do not require you to do the coding job, and so thus I already provided the code here. So you can just read them to understand how they works. For example, the first function print out the number, and here is the main function. You initialize PQE and give PQE value, and you compute the n. So n equals p multiply n. This is a multiply function. And then you calculate the phi n is the p minus 1 multiply n minus 1. This is shown here. And this is how they minus 1. And finally, you use the mod inverse function to calculate the d. So in this task, you just need to compile this function and run it. So we compile it, right? GCC lab 2 task1.c. We can give this output a lane. For example, output is task 1, and give this label crypto, crypto. Let's see. Oh, we do not. We are not in the correct directory. Right now, we should be good. All right, the task 1 is compiled. As you can see here, we have task 1. Now we task 1, run it. So we get the private key, right? So here is basically all the steps for task 1. So compile and run. So for task 2, we want to encrypt a message. So we already have N, E, and D here. And now we have a message M equals top secret. So the encryption computation is shown here. Ciphertext equals M to the E mod M. So if we check the library, we have the mod exp function, as we can show here. that you can calculate the IES equals A to the C mod n. That's exactly what we want to do the encryption. So before that, we want to transfer this message M to the hex value. The same format as N, E, and D, like that. So we use this command, Python -c print a top secret encode hex. So you can type this command as we shown here, Python -c print. Okay. Now the top secret. Okay, so encode hex. So you will get this hex number. You can actually copy it, and now you can do the code. So the code, as you can see, the encryption process is here. We replace the we initialize M, E, and D. Let's open the code here. Task2 code is over here. We have MEND, MED. So we encrypt the message as shown here. And we also actually add a decryption to verify the encryption message. Now, right now, we just, as you can see, we already have this message already copied here. So what we're gonna do is just compile this code. Dash task2. So we will compile task2. Let's run it, and we will get this encrypted message. To verify the encrypted message, we call the decryption, and this is the decryption. We use ENC to the D mod n. So we get the decrypt the message, and you can see the decrypt message is exactly the same as the message. So that means we have done the correct encryption and decryption. So compile and run, and after you get the decrypt message, you can transfer the hex value of decrypt message to ASCII like ABCD. As you can see, use this command. So try it yourself. So in task 3, is basically we do the same thing as task 2. We do the encryption. So in this time, we are already told N, E, and the private key. Now we have the ciphertext as usual, as we can see here. So since we already did the description in task 2, so we decryption in task 2, we just modify a little bit. So in the code, we can delete the encryption part, only have the decryption part, and we have ciphertext as you can see here. So let's go to the which mission. Okay, you have lab 2, task 3. So as you can see here, right now I had initialized my ciphertext, and I delete the encryption part, so I can decrypt the message. Okay, let's compile the task 3. Okay, task 3 does task 3. So we will get the task 3, and after we run, we can get this decrypted message. So in this case, it's a hex value, and we want to transfer to ASIC. That's this command here. Let's do it here. All right, it's Python -c. All right, print this is my decrypted hex, right? Decrypt the message and decode. We want to decode it. Decode with hex. So we got the password is DS, right? So that means the decryption is correct. All right. So here is the end of task 3. I will introduce task 4 and 5 in the next video. Thank you.